Hi, and welcome to my demo for my Stovetop monitor project. So the purpose of this system is to monitor stovetop usage and to send alerts when a stovetop may have been left on. So this is a stovetop, and if for example I've left the fire on, then the system should send an alert. In terms of hardware components, I'm using a particle Argon device, which you can see here on the breadboard, that has several sensors connected to it. So it has a SIT210 sensor, which you can see closer to the stovetop. I also did originally plan to use an ultrasonic sensor, but found intermittent issues in regards to voltage. So I've decided to just unplug that for the moment. I'm using a Raspberry Pi as well, which you can see here underneath the tripod. On top of that is a Pi camera, which provides video streaming from the stovetop. And in addition to that, we have some LEDs and a buzzer. Now in regards to software components, I'm using Google Cloud Platform. Particle Argon provides good integration into the Google Cloud Platform, so I've enabled those integrations. I'm also using a custom Raspberry Pi Python application, which I've developed. Now this actually provides three kind of subsystems running on multiple threads. So the first is a HTTP web server, which provides this dashboard. The second thread provides message subscription to pub/sub topic, and this handles events from the sensors. And another thread handles the monitoring logic, so it can handle the UI messages or the UI events and LEDs and buzzer alerts. So I'll just move on to a demo for the system. So first of all, we'll turn the stovetop on. We'll turn it on to full. Now we can see here right now that the dashboard is showing an average temperature of 29.16. So I've set the threshold for this to send a warning alert when the average temperature increases over 30 degrees. So let's put the pot on top of the fire. I found that this increases the heat. Now we'll move over onto the dashboard again, and we can see that the status has now moved to orange. So this is now flashing to indicate that the average temperature is now over orange. If we have a look at the Raspberry Pi LEDs, this LED is now flashing red as well. So that represents the orange, the same as the orange on the UI. Now I do have another status here, a red status, and the red status will send an alarm when the duration, when the temperature passes a set duration over a set times. So I'll just explain that again. If the temperature remains above 30 degrees for over 1 minute, then we will receive a red status, and in addition to that, we'll receive an audio alert through the buzzer. So as this is a real-time demo, I'll just hold on and see how what results we get. Now the reason while we're waiting for an alert, the reason why I used averages is I found a few outliers in the metrics or from the sensor readings every now and then. So you may have noticed there was a temperature reading of 158 that passed a couple of seconds ago. So I decided to use an average to smooth out the readings. Now while we're waiting for that buzzer to go off, if I focus in on the tables below, you can see that this represents the rolling data. So at the right we have the latest event data, and at the left of the table we have the oldest data. Now hopefully you can also hear that the buzzer is now buzzing. So we have an audio alert. We can also see on the UI at the status indicator that this is now red. Now just to do one more demo, let's turn the stovetop off. So hopefully the temperature starts to reduce buzzer will turn off and our alarm state can move to the orange. Now again, as this is a live demo, I'm hoping this happens soon. So I can see the temperature is decreasing, but not as quick as I would like. So I'm going to try putting an ice pack close to the sensor. Okay, so average temperature is reducing. Let's try the ice pack one more time. So it appears that the buzzer isn't going to turn off as the average temperature hasn't fallen as rapidly as I hoped. But hopefully this gives you an example of the project. And I hope you enjoyed that. Actually, as I spoke, the temperature has now fallen. Thanks for watching. Now that you've seen the demo, I'm going to walk through the coding for both the devices. So first of all, I'm going to start with the particle Argon device and just kind of show the integrations that I've set up. So I am using a Google Cloud platform integration. This will allow the particle device to publish its events to a Google pub subtopic, which I've defined here. So the integration itself is not too difficult to set up. You just have to make sure you have the appropriate privileges set up on your Google Cloud platform. Now moving on to the code for the particle Argon device. The code itself isn't too complex. Essentially what we have here is just set up definitions, basically setting the pins. Now I am using a SIT210 sensor and a SR04 ultrasonic sensor. So in setup, we do just basic setup here. Then most of the action happens in the loop. Now again, it's not too complex. It's essentially just getting the values from the sensors, checking if they are valid values. We're then publishing that, which via the integration publishes this content to a pub subtopic. Then we take a pause and the cycle repeats. So I have formatted the event as a JSON event containing humidity, temperature and distance fields. Now I'll move on to the code for the Raspberry Pi, which is a bit more complex. So I have put that onto a GitHub repository and I'll include the links in the project documentation. So there are really three files in regards to the Raspberry Pi code. What we have is an index file, we have the main, and a stovemetrics file which contains the class. So first of all, I'll start on the index file. This is what provides the UI. Now, as I mentioned earlier, the Raspberry Pi does host the web server, which provides the dashboard and the video streaming. So what we have is some JavaScript here. Now essentially what this has, or what this does, is set up a loop here, or a timeout function, to continuously poll the server to get the values. These are the event values that I received from the particle Argon, and it then populates element IDs on the UI. There's a few little calculations here, nothing too complex. we have some CSS styling, and then the HTML values here. So I'll then move back to the other code. We have a Stovemetrics file here. This is an interesting one. So this is basically a class that deals with all the metrics or all the data that's coming in from the pub/sub topic, and just basically just keeps track of all of them. So we've created a temperature list, a humidity list, and distance list, and event time list. There is also rolling metrics. Now, if you recall in my demo, I showed the table. This list here handles the rolling metrics. There are several functions related to this class, so we're able to set the metrics to create the rolling metrics. So this function here just provides the rolling metrics as a set of Python dictionary objects, so we can convert them to JSON, which can then be consumed from the web front end, which I showed, just the index.html, the JavaScript. Then there's some other helper functions here to get the rolling metrics, average metrics, and to set the health status. The health status here is what provides the flashing LED on the UI. I'll then move on to the main. Main is where most or all the heavy logic happens. So main contains quite a few imports here. So I'm importing the PyCamera library, socket server, threading. There's several more Google Cloud pub/sub here, and a few others. So I'm setting a few constants here. Now in my demo I did mention that the threshold was set to 30 degrees, so I have set that here. Ideally it would be good to set that via the UI front end if possible, similar with the alarm duration. So in the demo I had this set to 1 minute, but the code I've been using has 10 minutes set. This just defines the LEDs connected to the Raspberry Pi. Now I just set some project attributes or project settings, and I create the subscriber to the pub/sub topic. Then I create an instance of the metrics, the Stovemetrics class I mentioned just prior. Now these classes here I did actually get from PyCamera documentation here, and essentially these classes to help do the streaming of the video via the UI. But essentially what we're doing here is we're defining our URL paths, so index.html. I've created another path here for the metrics, which gets polled by the front end, and then there's the streaming video, which is just the streaming.mpeg file. Some additional helpers again for the streaming server. Then I have an event callback function here. So this is what's gets called from the publisher. From the Google pub/sub subscriber. And what this does is essentially just receives the event. Now this is an event that's published from the particle Argon device. It then converts this into JSON. It converts the time. So the time we receive from pub/sub is UTC. So I remove the UTC time zone information and convert it to local time using an offset here, and then I set those metrics to our metrics Stovemetrics object, and finally we acknowledge the message. The event subscriber here is, this function here is just to commence the subscription service, and I'll mention that later. So that runs in a separate thread. This function here handles the change in alarm status. So it goes through a bit of logic here. So first of all, we have a trigger metric list. Now this is just there to get the initial event value when it passes that threshold of 30 degrees. There's a couple of checks here. So we check if that temperature from the latest event is over that threshold. Now if alarm is on, then we do some extra checks here and we determine the difference in time. So in this case we're getting the event time minus the trigger metric time. Now if that event time is greater than our alarm duration threshold, which we set, so in the demo I used 1 minute, but in my codex up here, further up, I've set this to 10 minutes. But if that difference in time is greater than that threshold, then we move on to alarm level 2, and alarm level 2 will then engage the buzzer. So we move on. So again, a couple of checks here, if else conditions here, then finally, dependent on the actual alarm value, we'll either turn the LEDs off or on and the buzzer off or on. So there are two alarm levels I've set: alarm level 1, which correlates to the orange status, and alarm level 2, which correlates to the red status. And if both are false, then it correlates to a green status. And this just repeats again in its own thread. So finally, if we come to the main function here, what we can see here is that we've created a subscriber. This is and we provide the callback event. Then we create the event consumer, and we create that on its own thread. Similar with the alarm status, we create that in its own thread. So again, that's this function up here. And then we start both these threads independently. And then finally, we have the last section of code here, which then starts the HTTPS server. And this reads from the index file, or the index.html file, and then commences the video streaming as well. So that's just a walkthrough of the code. Thanks for watching.